Good morning, my dear students. I hope you all are keeping well and please be safe. Dear students, today we are going to discuss chapter 13, topic Fun with Magnets. Class 6th, subject Science. Many of us must have observed that if we leave the door of a refrigerator slightly open, it shuts down automatically. Have you ever thought how this happens? It happens due to the magnetic door closers fitted in the refrigerator. This property of a magnet is known as magnetism. That means in a not only refrigerator, many other things also. Just when we open and slightly close, automatically it will go and join. It's due to magnets. What is a magnet? Any substance which attracts pieces of iron towards itself is known as magnets. Now let us see the history of magnetism. This history observing the phenomenon of magnetism goes back to 600 BC when Greek philosophers found a certain type of black stone that had the power of attracting a piece of iron. So in ancient time, the philosophers found a black color stone which attracts iron. The story says that once a shepherd named Magnus used to take his herd of sheep and goats to the nearby mountains for grazing. He used to carry a stick with an iron tip. So he was having a long stick to control over sheep. So on the top he had iron tip. One day when he was resting, the iron tip of stick touched a stone. As soon as the stick touched it, the stone clung to it, means stick on that. The stone was a natural magnet and it attracted the iron tip of the shepherd's stick. This was how the natural magnet was discovered. Perhaps based on the name of the shepherd, that stone was given the name magnetite. Magnetite is made up mainly of a chemical called iron oxide. It was also found that if a long piece of the stone was suspended freely, it always came to rest pointing in the north south direction. This property of the stone was found to be very useful in determining direction. It was therefore named lodestone. Lodestone means loading stone, as it was used for leading or directing people. So, for leading and directing people, those days people used leading stone, which is called lodestone. Any material that has the property of attracting iron is called magnet. So, any material which has the property of attracting iron material is known as magnet. The name magnet is derived from magnetite. Magnetite is a natural magnet, that is called black stone. The property itself is called magnetism. The force that the magnet exerts on iron is called magnetic force. If you have played with a magnet, you would have observed that it can attract an iron nails from a distance. Thus, magnetic force acts from a distance even when there is no contact. Near to magnet, if you take nail, automatically it will attract. So now we have seen about this lodestone, also black color. Natural stone is known as lodestone, directing and leading people. Magnetic and non-magnetic substances. Materials which get attracted towards magnets are called magnetic materials. For example, copper, iron, nickel. Magnets can attract or repel other magnets and can attract any magnetic material even if it is not magnetized. Non magnetic materials such as wood, paper, plastic, and most metals don't get attracted towards magnet. So, if you take near to the magnet wood, paper, plastic, eraser, etc., it will not be attracted. So, already we have seen what is magnetism. The property of a magnet to attract things made of iron, cobalt, or nickel is known as magnetism. What do you mean by magnetic field? The area surrounding the magnet is which magnetic force is exerted to attract iron is known as magnetic field. So, magnetic field is very essential. Where we keep the magnet surrounding place, it will attract. Near or not very far, but mostly a particular place. Henceforth, it is known as magnetic field. We know that a magnet attracts magnetic materials towards it. We have noticed that the iron fillings cling to the magnet when it is brought near them. Can you tell what will happen if the magnet is moved away from the iron fillings? The iron fillings will not cling to the magnet. Can you explain why? The magnet exerts a force on the iron fillings. This force becomes weaker and weaker as the magnet is moved away from the iron fillings, until at some distance away it does not attract the iron fillings at all. Thus, there is a region around the magnet where its force can be felt. This region is called the magnetic field of the magnet. Thus, the space surrounding a magnet in which magnetic force is exerted is called magnetic field. So, around the magnet a particular distance is there. So, till that it can attract. After that it becomes weaker and weaker and it will not attract. So, there is a region. Till this it can attract. It is known as magnetic field. Magnetic poles. The ends of the magnets where the magnetic force is concentrated are called magnetic poles. Concentrated means it has more power. Each magnet has two poles, north and south. Types of magnets: natural magnets and artificial magnets. Natural magnets, they have low magnetic power. Example, magnetite, lodestone. Artificial magnets, they have a strong magnetic power. They are found in different shapes. What are the shape? Bar magnet, horseshoe magnet, then cylindrical magnet, dumbbell magnet, etc. So these are the example of artificial magnets. So these are the types and shapes of magnet: horseshoe magnet, bar magnet, disc magnet, magnetic needles, etc. This is known as magnetic compass. So making your own magnetic compass, it is given in your book. You can try it. So magnetic substances. A natural magnet attracts certain materials like cobalt, nickel, iron, steel, alloys of any of the above. These materials are called magnetic materials. Properties of magnets. There are five properties are there. First one is directional property. A freely suspended magnet aligns itself in the north-south direction. However, we keep automatically it goes and stands north and south direction. The end of the magnet that points towards north is called north pole, and the other end of the magnet pointing towards the south is called the south pole. Let us perform an activity to understand the directional property of a magnet. So just you can try with it. Second one is a magnet attracts iron objects. A magnet is found to attract pieces of iron and nickel. Third one is each magnet has two poles. The strength of a magnet is maximum at the poles and minimum at the center of the pole. So maximum north and south poles it have more power and strength, and in between center it has only minimum. Both poles occur in pairs and cannot be separated. If we break or cut the magnet into two pieces, we will get two magnets, each having north and south poles. If we further break cut these two magnets, then we will get four magnets, each having north and south poles. Fourth one, like poles repel and unlike poles attracts. So north and north it will repel. North and south it will attract. So this is known as like poles repel. That means same, north to north or south to south it will repel, and unlike like north south, south north will attract. Fifth one, magnetic induction. The phenomenon by which an ordinary piece of iron acquires magnetic properties temporarily due to the presence of another magnet near it is called magnetic induction. That means for certain time with the help of magnet it gets strength like iron materials. It is known as magnetic induction. After when we take out the magnet, it doesn't have the magnetic power. So this is when we cut, it will north and south, it will attract, but south north to north it will not attract. If you cut magnet, breaking a magnet, first one north and south, only two poles are there. When you cut into two, we are getting two magnets, that is north south, north south. Again if you cut into two pieces, we get at last four magnets. Each magnet will have north and south poles. This is permanent magnet, soft iron bar. Permanent magnet brought near to soft iron bar. So after sometimes when it is coming near to that, it will get all the magnetic power. When we take away, after sometimes it loses. It is known as induced magnetism. Magnetic compass. You can use a bar magnet, a needle, a cork and water for making your own magnetic compass. First, magnetize the needle using the bar magnet. Take the cork and insert the needle into it. Cork means a small piece of wood. Now, take a beaker with some water in it and float the cork in the water. Take care that the needle does not touch the water. Note the direction in which needle points. Now, rotate the cork and note the direction in which the needle points. Does the needle point to only one direction? You will notice that one end of the needle always point the north direction. The end of the needle which points to the north direction is the north pole of the needle and the other is the south pole of the needle, and hence your magnetic compass is ready. So this same activity last year all the children they have done. So dear students, I encourage and motivate you all to try this magnetic compass, to do this magnetic compass. Permanent and temporary magnets. Permanent magnet. If a magnet is very strong, it can induce magnetism in some magnetic material even after the magnet is removed. Such magnet is known as permanent magnet. Instead of the iron bar, if you magnetize a steel bar by induction, you will find that it retains more of its magnetism than iron when the magnet is removed. So here they are using the logic of magnetic induction. So in the permanent magnet only it can be done. Most permanent magnets are therefore made of steel. Steel is an alloy that consists mainly of iron with little carbon added to it. Another alloy used to make permanent magnets is alnico. Permanent magnets are also made of certain ceramics consist of mixture of iron oxide with other oxides such as barium oxide. These ceramics are known as ferrites. They are widely used in building components used in computer memories. Now let us see temporary magnets. Iron bar can be magnetized by induction. That already we know. However, if the magnet kept near the iron bar is removed, the iron bar will lose its magnetism. Thus, the iron bar is only temporarily magnetized by the process of induction. Such a magnet is known as magnetic induction. The moment when we remove the magnet, the iron bar also will lose its magnetism. This is known as temporary magnet. Permanent means for certain time it will have after removing the magnet also. Electromagnetism. Place a steel object inside a coil of wire solenoid. Pass a direct current through the solenoid. A magnetic field is produced on the solenoid. The steel rod is now placed inside the magnetic field. When the current is turned off, a steel rod is found to be magnetized for some times. Magnetization by stoking, single touch method. A piece of iron can be magnetized by using a magnet by simply touching the iron piece with the ends of magnets. This process is known as single touch method or stoking method of making magnets. Let us perform an activity to demonstrate. This is nothing but a small piece of iron you have kept. So after taking magnet, just you are scratching, means touching, going on you are touching. After sometimes it will get all the magnetic power magnetized. Next one is, already we have seen what is magnetic field. Earth magnetism. We have seen that when a freely suspended magnet is left undisturbed, it aligns itself in the north-south direction. This is due to the magnetic field of the Earth. The place where there is the geographic north of the Earth lies the magnetic south. On the side of the South Pole lies the magnetic north. We consider the magnetism of the Earth as a bar of magnet placed inside the Earth with its south pole towards the Earth's geographic north pole and its north pole towards the geographic south pole. That means it's a simple logic. We have to consider that the magnetism of the Earth as a bar of magnet placed inside the Earth with its south pole towards the Earth geographic north pole and its north pole towards the geographic south pole. That's all, just opposite. Next one is demagnetism. Here one more they have given double touch, means twice we can touch the, means two magnets we can touch it. Before we see uses of magnets, let's see demagnetization. A magnet can be made to lose its magnetism. Example, it can be demagnetized by hammering the magnet, heating the magnet above a certain temperature also demagnetizes it. That means when we hammer the magnet, it will demagnetized. The same way, after heating a particular certain temperature, it will demagnetize. Precautions while handling magnets. First one, do not heat magnets. We should not heat magnets because on heating magnets they lose their magnetism. Second one, do not hammer or drop magnets. Simply, we should not throw it. Magnets should not be beaten with hammer or drop on the ground because they lose their magnetism. Keep magnets away from computers, cassettes, and magnetic units. Cassettes, cells, and computers, certain magnets as the data of their function depend on the principle of magnetism. Keep the magnets away from such objects as they may affect the magnetic field of the magnet placed inside. So when you keep all these things, your data, everything can erase because of magnetic field logic. So always you should not keep the magnets near to cassette cells, computers, mobiles, etc. Magnets should not be stored properly. Should be stored properly. While storing the magnets, we should keep the opposite pairs of the magnets on the same side with the block of block of wood between the bar magnets. Also, two soft iron keepers should be placed on both sides of the poles, north pole and south pole. In actual, we protect magnetism of magnets. It will not lose its magnetism. At last, we are going to see uses of magnets. Magnets are used in most of our day-to-day applications. Some of these are mentioned below. Magnets are used in a compass to find direction. It is used in factories for lifting heavy masses of iron. Masses means weight. It is used by surgeon in hospitals to remove steel splinters from the wounds, even eye. It is used in construction of telephones, electric bells, etc. It is used to separate iron and steel from non-magnetic materials. And also it is used in credit cards and ATM cards. Information is stored in a magnetic strip. Audio and video tapes and computer hard disks use magnetism to store information. Magnets are used in dynamos, electric motors, loudspeakers, and telephones. Also, it is used in radio, television, and computers. So, this already we have seen. Dear students, we have completed. It's a very small chapter and also it is very interesting. By doing, you can learn more. So, here there are many activities. Try to do these activities and learn it. Thank you. Have a nice day. If you have any doubt, you can ask me. Thank you.